Good afternoon, this is Lee McWhorter. Welcome to the second session of Cryptography and Access Management that began on 5/14. So this is the second week. We covered the first 5 lessons last week, so this week we're going to cover the last 6 through 10, last 5 lessons. We have a bunch of stuff to cover. Of course, last week we covered all the first 4 lessons were all about cryptography. We talked about the different cryptography algorithms. We talked about common algorithms, went through sort of history of the algorithms, and then talked about wireless, etc. And then we began to get into some of the access management concepts like AAA, authentication, authorization, and accounting. Stuff like that. And so now, as we move into additional stuff about access management, we actually take a little detour because it's real important actually. We've talked about risk management before, risk assessments, very briefly in the intro course to security foundations. And this is a case when you start talking about access management where risk management is very important, a big important and related factor. So we spend a little more time on risk management now. So what is risk management? Well, risk management is the managing of the risk that your organization faces. Remember, we're trying to protect the organization's infrastructure and its IT, intellectual property, and confidential information. And so in maintaining, of course, our confidentiality, integrity, and availability of said resources and information. And so in general, we do risk assessment at sort of a company-wide level to decide, our priorities. I've used examples before of, a company that makes a lot of money on the web will spend a lot of money to protect that website versus a company that pretty much just has a sort of a give us a call, come on in kind of website. They're not going to spend as much. So, and everybody have to look at the risk that they face, but then they have to do some form of analysis of that risk so that they can come to those kind of classification decisions. There are 2 kinds of risk assessments you can do. You can do a qualitative risk assessment where you basically say a risk is a high risk, a immediate risk, a low risk. The impact is low, medium, severe, extreme, just catastrophic, whatever your categories are. And if you don't have any other choice or way to do it, or it's a kind of a quick and dirty, then that's better than not doing a risk assessment at all, because it will give you at least some idea of how to prioritize how you're going to respond and how you're going to set up policy and where you're going to spend your resources. But ideally what you want to do is do a quantitative risk assessment where you actually put dollar signs to it. If this website goes down and we make so much an hour, then we can figure out how much it's going to cost us, plus add in some costs for remediation, getting that fixed and back up and running again. Over time, maybe lost customers in the future, and we can put some dollar amounts that are pretty solid estimates and forecasts of what the impact would be of various things happening. So while that, of course, is at the kind of the big level, then why would we be talking about it in the context of access controls? Well, because access controls are one of our in the broadest sense, one of our main weapons for controlling information, controlling access, not only to data, but to systems themselves. And so when we look at how we're going to decide who we give access to data into different systems, in a sense, we have to do some risk analysis. We're managing risk. If we want to make things easy, we can just give everybody in the company read access to all the files on all the shares and all the servers. That's easy. That's convenient as all get out, right? But of course, the first time a crypto malware gets on somebody's computer and then can run rampant through the entire network and basically write to every file because we gave everybody write permissions, then everything will be encrypted and will be pretty much shut down. So we don't want to give everybody. So who do we want to give access, and to what access? And how do we make those determinations? Well, it's a mini exercise in risk assessment. What happens if I give? What are my risks? What are the possible outcomes? What are the possible costs of downtime and lost data and overtime, restoring from backups, and et cetera, if I give somebody access or if I give everybody access? And so by doing a degree of this analysis, as you think through access control, then of course it makes a lot of sense. Then you're starting to think, okay, well, the gain of giving everybody access and read and write to everything is that it's easy. But the risk is that, oh my gosh, anybody can accidentally delete stuff. They can change things intentionally, insider malicious kind of stuff. They could do something like get a virus on, and then because that virus is on that machine, that attacker or that virus can spread like wildfire to every other system, or encrypt every file if that's the case, or just read and transfer every file, right? So yeah, we don't want to give everybody read access, and and definitely not everybody write, but in many cases we don't want to give read even to people. Not everybody needs to be able to read everything. And so we start looking at who needs access and what are the risks involved of giving people access. So, basics, information, you know, we're going to have to give, generally speaking, it's pretty common to give, say everybody in the company access to certain information, maybe some basic HR information. Maybe there's a share or a folder or an intranet site that has, HR paperwork and forms, and you can fill out a vacation request and, different things like that. There are certain things that everybody has access to. And of course, so given that we need to give everybody access to, then those are things that if there's any issues there, risk of those systems going down or impact if they do go down, then we're going to have to take additional action to protect those systems because we can't limit everybody. But in other cases, of course, we can limit. We don't need everybody to have access to the financial information of the company. It is pretty common practice that actually only a handful of people, senior managers, and then senior people in the finance department would have access to all. But even within a large organization, the finance is usually broken up into multiple areas. It's probably, given your interest in this field and experience in this program now, you probably never done an AR or AP job, but that's a pretty common role in organizations. The companies I've worked for, we would have people whose jobs were to handle the AR, the accounts receivable. And those people could send out an invoice and take back money in from clients, but they had no permissions to read and pay bills for our vendors, things like that. And then we had people on the other side who could obviously put in bills that came in from our vendors, and then they could pay bills. And then we had other checks and balances on that finance system of if it was over a certain amount, a higher person had to sign. If it was over another amount, 2 senior people had to sign. And so that's just the financial controls, right? But that dictates some technology controls too, right? The AP people need access to the AP part of the accounting software, but they don't need access to the AR part, and vice versa. And only your senior, accountants and bookkeepers need access to everything. So by doing a risk assessment, we can figure out what makes sense and where we need to draw some of these lines. Make sure. Now, of course, one of the things that we have to be aware of with regard to access control and doing this risk assessment is that there are a number of access control risks, right? If we give too much access, then that's a risk in and of itself. If we give too little, we can fail on our availability promise if people can't access the information they need to get their job done. So we have to find that balance. So let's assume we found that balance though. Okay, so we feel like we've done the right thing. We've got some public information. We got information locked down to the appropriate people based on however we've set up our access controls. And, we've set up permissions in our files and our servers and our databases, and we feel pretty good about that. But we still have risk, right? Somebody could crack a user's password or manipulate it with social engineering and get in. And so we still have to be aware of the risk, even with proper access controls, that they could be supplanted and gotten around. And so we have to think through another layer of what do we do after that? How do we monitor that? How do we have some logging? Do we have some accounting going on in the background? Why is Susie logging in on Saturday when that's not a normal time for Susie? She usually doesn't work Saturdays, things like that. Do we have some systems in place to help us manage these risks and some of these issues? And so, like I said, sort of understanding the risk management principles and then risk assessment in general, just like a lot of these concepts, we're going to use layered defenses throughout our whole history of working in this field from now on. You're going to think layered defenses over and over and over again. You're going to think about how can I improve the layering of my defenses and my controls. And just like we're going to use, other types of standard principles, best practices, again and again, we're always going to change default passwords. We're always going to do these things. We're going to use risk assessment. As a matter of fact, it's a kind of thinking that if you get the mindset into your thinking, and you've done it a few times, you start to look at the world in an entirely different way. You look at the world, you look at something and realize, and your mind starts calculating the risk of what if that process goes wrong, or what if somebody sort of plants and gets around it. So it's very important. The 7 domains of the IT infrastructure are also mentioned again in this chapter, which is once again a review from, I believe, actually the second, the system admin class, actually, not the very first class. But nonetheless, an important model of, once again, why we talk about that here is that we have access control issues in all of those different domains. We need to set rules and policies for our users' access. We need to set rules and policies and group policies, for example, for our machines' access. We need to set policies on who can access servers, router closets, routers, all different kinds of infrastructure, backend databases, etc. So once again, by using that IT model of being able to break the infrastructure into the 7 domains, we have the ability to then isolate and say, okay, let's think about the user. What do we need to do for them? Let's think about the workstation area. What do we need to do to set access controls there? Server area, LAN, WAN, etc., all the domains. So then we start to talk about, as we move on in lesson 7, different types of access control systems. And these are important to understand the different ones. There's a whole different number of ones, and many times they're presented as acronyms. ACL is an access control list. And there are all different kinds of access control policies and models that we can use. And they'll usually be abbreviated, and they show up on Network Plus, Security Plus type of exams and etc. So an access control list, an ACL, is one of the ways that we can control access. We can have a physical access control list of only the people on this board can come into this room, or only the people with these badges can come in. That's an access control list, right? The person knows not to let anybody in except the people on this list. And of course, we can do that at a file level. Only the people on this list can read this file. That's a computer access control list. We can do it at the server level, the router level, we can do it everywhere. But there are different ways we can set up access control lists. And so there's a number of them. There are different models. So the first one, and the most common, is what's called DALC, which is discretionary access control list. And that's pretty much the default of Windows, say at home, your machine, or for that matter, Mac. You are the owner of your files when you create a file, and you can choose to share them at your discretion. If you right-click on a file in your Windows File Explorer, you can go into Share With, and of course there's the home group or remote, or you can choose these different options of who you're going to share that with. You could set up different users and then only share it with a particular user, or you can share it with your home group, etc. And so, but that's at the discretion of the user, and that's kind of the basic. And sadly, in many cases, very small companies, that's the way it works within their networks. At home, that's the way it works for most people. That most people don't set up more elaborate access control systems beyond just each person can decide, okay, I'm going to create a folder and share some stuff, from my machine to my wife's machine, for example, and we can do that kind of thing. Now, there are other types of lists. There is a system access control, where the system helps control some of that. There is mandatory access control. And this is a case where if it's mandatory, then you're usually doing this through, say, like group policies, so that the user doesn't have control anymore. When a file's created, it has default permissions. They can't change it depending upon what type of file. It's all been rule-based. And of course, funny enough, there's 2 more models as well: rule-based and role-based access control systems. Rule-based are, you set up the rules. This type of file, or this, from people in this department, then they have certain rules about those files, who can and can't see. And then role-based is based on the roles. And so sometimes one of the comparisons that will be made is sort of the military approach of, having a secret, a top secret, a super secret, whatever, all the different, classified, highly classified, for your eyes only, whatever the different levels are. And then so based on your role, then you have access. So there are advantages and disadvantages to all these different models. They are, it's obviously much easier to leave people to do it themselves. Just leave your own network discretionary, right? And let everybody decide their own sharing rights and permissions. That's not usually the best approach, especially in an enterprise, but it does work easy for peer-to-peer and, for roommates in college and folks sharing, folks and family sharing, amongst themselves at home between, spouses and kids, whatever. But even then, you might not want it completely discretionary. You might want to be able to set it up so, just like parental controls, the kids can't get to certain things, can't share certain things. That can be managed discretionarily if you're the only person. If I was sharing to my household, to my wife, and I could set up, what I want and don't want her to be able to have access to, right? But that's at my discretion. And as your organization grows and more people have that discretion, then it becomes a very complex, and there could be obviously gaps and even issues where, say user X creates a file, shares it with user B, who then has the rights since they were shared by A, but they share it with D, and A never expected D to get that file. And maybe they don't even have, the job role of permissions that they technically should, but because it's all discretionary, then it could happen when you have these holes. So that's where the other systems, either you set up mandatory systems that the systems control it, or you set up sort of rule or role-based systems where, and of course, there's the reality of there is some degree of hybridness in this, that these different systems will be used in different contexts. So, within maybe one work group, they may have on their own machines a degree of discretionary to share, or they may have a common shared folder where that group can share, but it's not everybody in the company necessarily. But within that, maybe they have a degree of discretionary, but then when they go, of course, to access other things, or when other people try to come in and access their resources, then say a role-based system comes in. And so if you don't have the rights and you don't have the role high enough and the need to know, or the top secret clearance or whatever, the way it's been set up in your system, your user writing management system, then you won't be able to have access to that data. And so there are multiple ways to go about doing that. And then because of that, we talk a little bit about some of the different authentication models like Cerebros. And we'll talk, I believe, a little later about Radius, but there's different, login models, different, and of course, one of the things that's become very popular is what's called single sign-on, because things have gotten so complex and there's so many systems and so many computers. And so, as an organization grows, if you have to log into your PC, and then you have to log into your database application, then you have to log into the network share to, get access there. And then, maybe you've got a cloud server for something else, and you've got an intranet for something else. And all of a sudden, an employee that's just doing a support job has 7 logins to this organization. That's crazy. And of course, somebody's got to manage all that with the, very high likelihood that maybe we don't set something right because we've got so many permissions to set up every time we onboard and bring a new user and hire somebody, or we forget to delete all those things and change them back when we delete that user. And so the single sign-on idea is that you can sign on to the system in some form or fashion. There's multiple ways to do that. One of the most popular today has become a cloud-based. And usually what happens is that you authenticate against that cloud provider, or if you're running in an enterprise, against your own authentication server. And then in a sense, and there's different ways this can be done, but through a digital certificate, a token, basically some kind of digital key, you're validated. And then at that point, you don't have to sign in again to other things. When you go to access them, your token is used to see if you have the appropriate level of permissions. And so, of course, it makes it much easier. You can think of before the cloud and everything else, in a sense, the Windows networking, the world of the Windows domain controllers, you could log into a Windows machine that's on a domain, and that, at least in that local network, is a single sign-on. So at that point, if you have access, once you've signed on your machine and joined the domain, your policy will give you access to maybe a shared folder on the server or not. Maybe you can use this printer or not. And those rights can all be set. And so through one sign-on, but of course, then as other systems came out that weren't just your Windows and networking, your local network, we had cloud-based and servers and other stuff. Then we've had to, continue that model into a broader format. So that is one to consider. There's an advantage of single sign-on that it saves a lot of administration. But of course, if that one single sign-on is compromised, then the compromiser, the attacker, has access to all of those resources in one fell swoop. So then one of the things that we then talk about next is, and we've mentioned these before, I know they've been mentioned in other classes, but it's something that's really important, is the states of data. Data can be referred to as in 3 different states, and in cybersecurity, it's our job to protect that data in all of those states. And so the data can be at rest, sitting just on a hard drive or an archive tape or whatever media. Data can be in transit, it can be in communication, in motion, if you will. So data at rest is on storage somewhere. Data in motion is transmitting over the network or over the internet or over cellular or satellite, whatever the media again. And then of course data in use, where it's actually being used. It's in the memory of somebody's computer and they're manipulating it. So when you think of something like, say, an accounting software package, at night, everybody's shut down. There is a copy of the master database of that, say, QuickBooks or Peachtree or SAP, Oracle accounting, whatever. And that data is there. It's on the machine. It's at rest. And so, of course, we have to protect that. We have to protect the entire network. We don't want somebody to be able to break in, get onto that server, and copy that file off while it's at rest. So there's different things we can do, of course, through access controls and access management, as well as additional things like encryption and things like that, which fit in with the first part of this course, right? Cryptography. So that, maybe, and I've seen things like that where outside of normal hours, a file that is normally not necessarily encrypted because it's in use is encrypted and then decrypted overnight, so that if somebody, a janitor, a hacker, or whatever was able to get in, they would only get a scrambled file and have no way to do anything with it. And of course, it can be encrypted in all times while it's on the data, but then of course, at some point, let's say people come in the next morning, they boot up the software, and we're not encrypted, and then we're having to transfer that data. Well, most accounting packages will use some form of SSL, SSH, some form of encryption built in, so that obviously an employee can't just sit there with a packet sniffer all day and watch as the accounting person at their desk is entering stuff into the database. So that's encrypted. So we want to encrypt that communication. Encryption once again comes in. And we also want to make sure that we potentially use other tricks, VLANs, to separate that traffic so nobody can sniff it. Only the people in the accounting department need to even see that kind of stuff, for example. And so as you can see, encryption, whether it's file or full disk, is a great way to help, and then access controls to protect it while it's at rest. And then of course backups are part of that too. When it's in transit, it's generally going to be encryption in one form or another. Even if you have some old legacy application that has no support for encryption, and you need to, say, have access from a remote facility to that legacy application, you can wrap that connection, create a VPN tunnel, and then everything will be encrypted, even if the underlying legacy systems protocols weren't encrypted. And so we want to use encryption in some form or in protection to, our private networks, however we want to look at it, isolated segments, to be able to keep that communication, that information secure while it's in motion. Then we have the issue of while it's in use. While it's in use is the hardest area to defend against because it's in use. It's digital on the disk. It's digital while it's going across the wire. And of course, because it's digital, we can scramble those bits with encryption. And because it's digital going across the wire, we can scramble those bits going across the wire. But at the end of the day, when that information comes up in front of that accountant on their screen, they don't want to look at it in ciphertext, right? They have to look at an invoice that they can read with a name and address and billing and a number, and they can decide, apply a payment to that invoice. And so at that moment, the data has become analog again, because the user is seeing it on a form, and the user theoretically could take a screenshot, right? Or a hacker who has taken control of the machine could be taking screenshots. Or a user could take pictures. I mean, the old school, we've all seen it in some movie, probably a James Bond, but the spy or the hacker could be, has broken in or gotten into an area, and a little bitty camera takes a bunch of pictures real fast so they can get the secret plans. Well, of course, if the data, that is the challenge. How do you deal with the data in use? You want to have some really strong policies, NDAs, things like that, acceptable use, and to make sure that those people aren't taking that data out. You might have a group policy that fires on or alerts if. And technically, I believe you could even disable the ability to take a screenshot through sort of the standard Windows mechanisms if that was necessary. And so you have to deal with that. And of course, because the data, even if it was encrypted in the disk and encrypted over the communication, it has to be decrypted so the program can really use it. And so if a hacker has a Trojan or something on your machine and is listening, they might be able to grab the information directly from RAM. So there are things, of course, we can do with access control, limiting that so we limit our risk, locking down systems even more secure if they're really important, if they're the systems that are being used to access this super secret confidential data. We may want to do things like I said, disable the ability to take screenshots, disallow people from bringing other devices like their phone into that secure area so that they wouldn't have some way to take that data out. I have literally seen companies disable physically or with super glue, for example, like make sure that nobody can put a USB stick into that computer or take those components out of the case, so that remove a CD burner. This machine is for working on this accounting. It doesn't need that stuff because you could theoretically, burn that data to a disk and just drop it in your backpack and head out with it. And so we have to think about those areas and their impact on our access control and our access management. So let's see. So of course, one of the big things besides our access controls is tracking. And of course, one of the things that you'll get into, actually, I'm trying to remember that coursework. When you finish this class, you actually get a lot more about tracking because the next class is logging and monitoring. So that applies. And by logging and monitoring, we can do a back end, comparison against what we think is happening at the front end. Are rules being followed? Are people actually doing what they're supposed to do? Are there any anomalous things that are going on? And they will help alert us to potential problems as well. So then when we talk about 9, let's move into lesson 9. It's implementing access controls and securing remote access as well, because that's a unique piece of the equation and becoming more important these days. It used to be everybody went to the office, worked so many hours, went home, but now we have more and more flex time. We have more and more remote workers. I'm a remote worker in almost every capacity of what I do these days. Not only this here video, but I do my work. I check my code into repositories. I work in the cloud. It seems like it's very seldom I go to an actual location that is a client location, if you will, anymore. It's all virtual these days. We meet online, we discuss things, I can remotely control systems, etc. And so remote access and doing it securely is very important. And so that's what lesson 9 is all about. And so one of the big things that we've talked about before is that everything we do to help secure our network, we're in a sense implementing a control. And so when you start thinking about access management and implementing access management, you're basically thinking about what controls are you going to implement? What model are you going to use? Are we going to use the discretionary model? Maybe if we're a small startup with 5 of us in an office, we'll start that way. But at some point, we'll grow up, mature, reach a point of risk assessment that, okay, we're running a risk here. At some point, we don't need everybody to have access, so we're going to adopt some other model, role-based, mandatory, whichever. But then we're going to put controls in place. We're going to put the rules in place that power that. We're going to define the roles if we're using a role-based system. You know, and then we have to go in and configure our system to support that. So if we're going to use a role-based, we have to define roles. What are those roles? Users, confidential access, secret access, top secret access. Okay, so we have 4 levels now. So we're going to go in, we have to, you know, set up groups and define our users by those roles, so that then when we then define permissions based on those roles, as the users are navigating around through the resources, they will get access to the resources they need based on the roles they've been assigned. And so we have to think about those controls. And then of course this leads to, if not the creation, if that it's in the first place, but it may very well lead to the modification of existing policy. You have an acceptable use policy. When you started off with 5 or 10 people, you may have said you can use the computer to surf Facebook or do whatever, but later on with different roles and locking down and getting tighter in these things, maybe you got a defense contract and all of a sudden you've got a whole higher level of security you have to worry about. So you start changing things, and so you update your policies and you update. Now instead of having to have a certain length password, we got a different password policy. Or now, you know, we have to educate everybody about how this role thing works. Instead of everybody just logging on and getting access to everything, they're going to log in tomorrow and they're not going to have access. And of course, with a new rollout, we're going to probably have some trials and tribulations. Somebody's like, hey, but I needed that data file that I used to have access to because I had access to everything. But now that you've limited me to accounting, I can't get to that marketing data. And I did something with that every so often. And so you'll have to adjust and your policy as you go, so that you can continue to, one, protect the data, but also, once again, as I always come back to, we have that CIA part of the triad. The confidentiality integrity is what everybody gets focused on. Is protect the data, secure it, lock it down, encrypt it, firewall, protect it, sandbox it, whatever, every word you want to use, throw at it. But then we forget about, so focused on that, we sometimes forget about that our job is to do that. And so we want to keep that in mind equally. That's that balancing act. We want to make sure we're enabling our employees and our organization to accomplish those objectives. We want to do it, and we want to do that as frictionlessly, as seamlessly as possible. But at the same token, we have to provide a level of security that is appropriate to the data that we're protecting. So there are various and sundry standards that we can look at. And we talked about, there's some standards bodies mentioned that talk about access controls. I'll leave you to read about those. We've talked about standards bodies and frameworks before, so these are some that would help you when you looked at this area of things. And then there's, of course, multiple different ways to talk about remote access. VPN is one of the most common ways to allow a remote worker in, but you can also have secure web-based access through HTTPS. Different and sundry models depending upon the level of security. And I mean, even to this day, you still can, if you had to, for whatever the reason was, you could have a point-to-point connection. Theoretically, let's say you had a work-at-home super genius programmer and worked on your team, and the reason he worked at home, he was so super genius, he could pretty much demand his salary and his working conditions. I'm just making this up. Or she, I'm not trying to be, whoever. You're a programmer, though, you wanted them. You needed them to do this module, to add this functionality. They're the expert in the field, and you've hired them, but they've said, I work from home. And so, but they're working on a super secret government project, and they're supposed to work from home. Well, we're maybe not even going to trust VPN over the internet. If it was so critical, we might set up secure point-to-point links, or at least through our providers, like our carriers, our phone and cable companies, we might set up a couple point-to-point links. So there is basically a direct circuit between that person's house and our network, and there's not an internet involved at all. I remember the last time I saw something like that done, it wasn't directly for security, like letting a remote worker in, but I had a friend that worked for Dell years ago in their custom server integration group, and their job was to, Dell might sell a big company on, do a complete upgrade. Here's 5,000 machines, 400 servers, so many printers, here's the whole thing. And they would sell it as a turnkey package. And it was actually fairly impressive, especially given how many years ago this was. But so that the machines would come off the assembly line, and then they would shunt down to a separate sub-assembly area where my friend worked. And that's where they would do the custom configuration to set up all these machines. So as a quick example of using a point-to-point connection, they were having to do a replace for a company up in the Midwest that was a huge company. I mean, they were in a 20-story building. There was going to be thousands of machines, and this was all being scheduled to be done in one weekend, believe it or not. So they had to set everything up, image all the machines, set up all the software, and get everything ready so that they could ship that up there. And then a bunch of contractors and Dell employees were going to come in 5 o'clock Friday and start taking everybody's machines out and plugging new machines in, replacing servers, everything else. And the idea was that they were going to come in Monday morning and log into new machines, but everything was going to be exactly like it was before. Same username, same domain, everything. And they pulled that off. But one trick was that when you want to add a domain, and some of you will probably know this from previous networking experience, but if not, this will be new to you. When you bring up a new domain controller on a Windows network and that you want to take over, you can't just bring it up in isolation and say, hey, you're going to, no, it has to join that domain. Literally, as part of the install process, as you set that domain, you have to set it up as a secondary domain controller to the primary. So here, my friend is in Austin working for Dell, and he has hundreds of servers to set up, multiple of which are going to be domain controllers, including some that are going to take over as the primary for certain subdomains in that network. And he's in Austin, and they're on a network in Chicago. So they had to set up a point-to-point ISDN connection so that literally when that machine came around and came to that step of the install process, Ray could plug in a network adapter that went through that router and that point-to-point, and then that machine was literally on the Chicago network, and it could come up, it could talk to the domain controller, join the domain, back up, have the domain tables and everything it needed, user list, and then be shut down at that point and boxed up and shipped. And then, of course, when the folks brought it up on the network, they were able to bring it up, and they were able to say, oh, okay, we've already talked. You were on, I validated you as a secondary domain controller, and then they would demote the old one, promote the new one, and they could take the old one offline, and this one took over. But that point-to-point connection was needed for that one secure, it was secure. Obviously, they didn't want to run that. You couldn't do it over the internet, and it wouldn't have been practical with VPN and safe. So that was, in a sense, how they set those machines up remotely to be part of a network halfway across the country. So if you needed to, in the absolute sense, that's still an option. Very expensive, but an option. So, and then as we get into our last chapter, it's really an important one because it's really where things have gone. As you remember from last week, we talked about encryption. And when we get down to it, you can kind of break it into symmetrical encryption, where there's one key, a shared key, or there's asymmetrical encryption, where there's pairs of keys. And that's really where for the most part, the world is going to, is these public key infrastructures, even though we're really in a hybrid, because even when you do like a connection with like your bank or Amazon, where you get that green encryption, the reality is that there's a public-private key exchange and a digital signature verification, and then what's encrypted is a session key, a symmetrical key. And that's going to be used the rest of the time communicating. And so it's really the public-private key is being used to validate, cross-validate, and then share the key secretly. Because it's, symmetrical is faster by a long shot than the public-private key, asymmetrical encryption. So for that, once we get that, but of course, without having the key in the first place, we can't start a secure communication. So we have a hybrid mode there of the public-private keys are used to shake hands in a sense and validate, oh yes, this is Amazon, and okay, cool, everything's good. Now we're going to use this encryption protocol, and here's our agreed encrypted key. And now we can just start streaming back and forth using the same key. But public-private key, asymmetric cryptography is growing in importance and used in many, many areas. And so we end up seeing something, which is what lesson 10 is about, called PKI, which is public key infrastructure. And so beyond needing to understand how, okay, I want to communicate with you, so I create a public and a private key, and I keep my private key hidden, but I give you my public key, and you create your own public and private, and you keep your private and give me your public. And now with that exchange of public keys, if I use my private and your public, to encrypt something, mathematically, you can use my public and your private to decrypt it. And as a matter of fact, you're the only person in the world who can do that because I used your public. And you have, well, everybody has my public, only you have your private. So it's a great mechanism. But that once you start going down that road, something's got to manage that. And that's where public key infrastructure comes into place. When you think about what's happening at the web level, like Amazon or your bank, and there's a public key infrastructure going on. They don't really look at it quite the same way, or they talk about secure SSL, secure HTTPS, but that's what's going on. The provider, Amazon, has gone to somebody like Network Solutions, GoDaddy, whoever, and said, I need a digital signature. I need to validate so that I can have these secure communications. And so, of course, the provider then validates, and depending on the level of the certificate, they literally may, send people, to make sure the company exists, and that they really are there. And they really control those domains, and they control those servers and those IPs. And so there's different levels, whether that's automatically checked just by base or a quick call, or it's the highest level lock bar, very expensive a year to renew, but can totally validate everything. Then, once that's done, then that's that the provider, the Network Solutions or whoever, they're being a key provider. Their job is to be that validation. So when Amazon sends you their digital certificate, that digital certificate includes their public key, of course, but it also includes a signature that says, I am who I say I am. And matter of fact, it's been co-signed, in a sense, with the public key encryption by VeriSign or Network Solution or whoever. And so your browser in the background immediately goes out and says, hey, I was given this certificate by IP whatever that claims to be Amazon. Is that all valid? And then using cryptography, they will compare their information and make sure the keys match, and that, yes, I signed that certificate and I've authenticated that that is Amazon. And if you trust me and you trust them, and now we can exchange our keys and begin cranking out our ordering whatever we're going to order on Amazon. So, but if you're running and using public key inside of your organization, then you need your own infrastructure. You need what are called CAs, technically, certificate authorities. And there are different levels of certificate authority. The top end of the root certificate authority servers, and just like the top DNS servers, are run by some of the main providers and backbone and infrastructure folks. The root certificate servers that are out there for validating, like Network Solutions and VeriSign, they run these servers. But then, of course, if you're going to run public key infrastructure inside, you're going to issue public-private keys to all your staff or all your network devices or all certain processes, whatever. You got to manage those keys, right? You got to issue them. You got to be able to securely store them if that's the case, escrow, et cetera. And so you need an authority to validate those, to be that certificate authority. And then there's different levels of that, from the root to your prime to the intermediate authorities. You can even set things up so that organizations that each have their own public key, private key infrastructures can then set up a certificate authority that sort of ties them together, and then they can work together like a joint venture or something, using each other's keys, to validate each other's servers to validate their users for each other. And so there are a number of things that you need to be aware of that. One of the standards is the X509 certification standard. That's what all this is based on. And so there are a number of things with regard to, like I said, you need a certificate authority, you need the registration authority, you need some kind of certification server, you need the ability to manage certification granting as well as revoking. That's actually one of the big things. If somebody leaves the organization, you need to be able to revoke those certificates. If somebody's website, is compromised at that level, they need to be able to revoke those certificates so that somebody isn't able to fake that they're really Amazon. If the provider of Amazon certificate got hacked, then Amazon would have to revoke that certificate and issue another one. And then we would want to put it on the revocation list so that worldwide somebody doesn't have a fake signature now because they've cracked and try to say I'm Amazon and then have it show up and validate, because they have that ability. They've got those keys. So key management is the public key infrastructure, is for, obviously if you and your friend are going to use PGP or, GNU privacy guard and going to send each other messages. You just need to make your own keys. When we do things for the web, as the individual users, that's all kind of taken care of. For us, our our browser will generate some keys, and then of course the providers will have taken care of the keys at that level. But in an enterprise situation, if we're going to implement that on a larger scale, then we're going to bring some of that many times in-house. We're going to run our own certificate authority. We're going to run our own registration authority, our own certificate revocation list, and we're going to manage the keys within our organization that we give to people. And of course, in many cases, it may not even be they're aware. I mean, it may be part of onboarding an employee, just like normally you would say, okay, here's your email, sign the acceptable use, here's the HR policy book, welcome to the orientation, you're a new employee. Your initial username is this, and when you log in, it's going to ask you for a password. And instead, if it's all public key and private key infrastructures, they may have literally already installed keys, assigned keys to your workstation as part of the onboarding process. And that way, when your machine, tries to connect to other resources, it can exchange keys and get into other, based on the key you were given and the rights you have. And then we can encrypt that communication between all those endpoints. And then as part of the offboarding, of letting somebody go or them quitting, we of course revoke those certificates. And many average users may not know whether when they sign in once and log into their computer, they may not know whether that's single sign in the cloud, that's Radius or whatever kind of server, or they're just validating to their machine and thus to their digital signature, and then it handles that. But these are the different ways we can handle access control. And so public key infrastructure is important if you end up working someplace where that is actually being implemented in the enterprise, and also important because there are definitely a few questions on the Security Plus test about things like PKI. What is it? What are these different elements like the certificate authority, the registration authority, etc. We are once again, back out of time. That is the end of crypto. I believe didn't see any questions when we popped in. So these videos will get posted here in another couple hours once I get my last lecture of the day done. And they will all get into the LMS, and I'll post links to them, etc. If you have any questions, as usual, hit myself or Joy up on Slack. If you direct message me on Slack, it'll pop. Even if I don't appear to be online, I'll get a notification to that. Otherwise, I try to check in when I'm not in class or in some other function, and at least once or twice a day. Sometimes I'm on for hours and hours, seeing if I need to answer questions. But anyway, have these up next few hours. And if you're having any questions, you got a little bit more than a couple days left to finish up. And hopefully I'll see you in logging and monitoring next week. Thanks.